Hello, Sec 3A Maths. Today I'm going to teach you work example 11, finding the general term of the binomial expansion. Okay, the general term is basically any term in the binomial expansion. So, you see, in the binomial expansion of a plus b to the power of 10, for example, any term in the center or any term that you want within the binomial expansion, you can write it as 10, whatever position that you want. This is A, this is B. For example, if you want the R position, this will be R, and this R plus what gives you 10? 10 minus R. So this is essentially what we call the general term. General term. Alright, so when you read the question, it says find the general term in the binomial expansion of x squared minus 1 over x to the power of 12. That's what we are going to do. We're going to do x squared plus minus 1 over x minus 1 over x to the power of 12. I'm going to rewrite this in indices. It's going to look like this: x squared minus x to the power of minus 1 to the power of 12. Now, what is the general term here? The general term is t r plus 1 equals to 12r x squared. This is minus x to the power minus 1. Now, remember, this r is here. R plus what gives you 12 is 12 minus r. Okay, but of course, we don't need to use the arrows because you all know that already. Okay, then you're going to ask me, why is it r plus 1? R plus 1 is because of the positioning. Remember, we start at position 0. So that is the r plus 1. Okay, you don't need to put so much emphasis on that. Just know that it's tr plus 1. Okay, so this basically means any term that you want in the binomial expansion. This is called the general term. And this is very, very important. Okay, find the general term in the binomial expansion. We are not done yet. Now we got to split up the general term. So this is the general term. We got to split up the general term into the coefficient. And the other one is called the x term. Sorry, it's just the x. Okay, so this is coefficient and this is just the x. Coefficient basically means number. X basically means x. So we got to split them up accordingly. Okay, before we do that, I'm going to split up one by one first. Okay, so if you see, this is 12r. 12r is just 12r. X squared 12 minus r. If you remember your indices, this power, you can multiply them together. You're going to have x to the power of 24 minus 2r. Now, the tricky part comes here, which is the minus x to the power minus 1, the whole thing power r. You see, the minus has an invisible 1 here, which means you can split up. This is essentially minus 1 to the power of r, and you have x to the power of minus r. So you see, once I split this up, everything becomes clear. What is number? What is x? This obviously is a number. This obviously is a number. This obviously is an x term, and this obviously is an x term. Now we are going to rearrange these terms. Okay, we're going to rearrange these terms. I'm going to put this here, the number with the number. Now this is the coefficient, and then the x will be x to the power 24 minus 2r multiplied by x to the power of minus r. So this is the coefficient. I'm going to leave it like that. And this, I'm going to join them together. Okay, indices, if you realize, the powers will add up together. So you get x to the power of 24 minus 2r minus r gives you 24 minus 3r. That's it. So remember, this is the coefficient, which is a number in front of the x. And basically, this is the x term. Okay, so this is the general term in a binomial expansion. So your binomial expansion has a lot of terms. This is any term that you want it to be depending on what position you want. So if you want position 5, you just substitute r is 5 and you get that term right smack in the center of the binomial expansion. So how is this general term useful for us? Okay, so this is our general term. Of course, the first step general term is not unarranged one, not arranged properly. What we want the general term is the one that's arranged properly. This is the general term. All right. Now they say part 2. This is part 1. Now part 2, what they want is write down the power of x in the general term. Very easy. Power of x is just here. 24 minus 3r. So power of x is just 24 minus 3r. All right. Determine the term containing x to the power of 9. I want x to the power of 9. Very easy. If I want x to the power of 9, part 3a, I just it just equate 24 minus 3r equals to 9. Because I want power 9 here. You see, I want power 9 at the 24 minus 3. I want x to the power of 9. I got to find out what position within the entire expansion that gives me x to the power of 9. So I just substitute 24 minus 3r equals to 9 and find out what position, what is the r that gives me that power 9. So if I were to shift it around, 24 minus 9 equals to 3r. 24 minus 9 is 15 equals to 3r. r is 5. So basically when r is 5, it will give me the x to the power of 9 term. So I'm going to substitute 5 inside that general term. So basically, it is the 6th position. So direct T6, because when I substitute 5 inside, is 5 plus 1 is 6. It's the 6th position. It's 12, 5 minus 1 to the power of 5. X to the power of, if I sub inside 24 minus 15, it will give me x to the power of 9. That's what I want. I want x to the power of 9. So if I press my calculator, 12C5, I get 792. So this is 792. Minus 1 to the power of 5 is minus 1. And this x to the power of 9. I get minus 792 x to the power of 9. That is the term with x to the power of 9. So you see how powerful this general term is. This is very powerful. With this, I do not need to work out the entire binomial expansion. If I want x to the power of 9, I just work out what I want. And that's it. Okay, the next part B, I want the term independent of x. Now, the term independent of x, what it means is x to the power of 0. I want x to the power of 0. So I just repeat the same working. So part 3B, 24 minus 3r, I just equate to 0. I get 24 equals to 3r, r equals to 8. Which means when r equals to 8, it's going to give me that term within the whole expansion that has no x in it, x to the power of 0 in it. So I'm going to substitute r equals to 8 inside, so it becomes T9 because r plus 1. So it's 12, 8 minus 1 to the power of 8 x to the power of, if I sub in 8 inside, 24 minus 24 is 0. That's what I want, x to the power of 0, you see. If I press my calculator, 12C8, I get 495. 495 minus 1 to the power of 8 is just 1, and this is x to the power of 0. X to the power of 0 is just 1, so its answer is just 495. Okay, this example number 11, is very important. You must understand this example. If you don't understand this example, please text me. I will teach you through Zoom. Alright? That's it for word example 11.